Alright guys, so let's also consider this other problem on the board. I think this question will also help to explain another Archimedes principle to us. The question says a wooden block 4 meter by 1 meter by 0.5 meter is floating in water. Its specific gravity is 0.76. Question says find the volume of concrete of specific gravity 2.5 that may be placed on the block, which will immerse 1. the block completely in water, and 2. the block and concrete completely in water. So this is a bit different from the first question we solved. Here we have a block. Okay, here we have a block floating on water. So this block is actually floating on water, so we can simply take this to be our water, and we have a block floating on water. Now the question says that okay, the specific gravity of this block was given as x is 0.76. okay, specific gravity of the block was given as 0.76. now the volume mass, now the length, width and depth of this block was also given 4 meter, 1 meter and 0.5. so let's say we do an isometric diagram of it as well. The length of the block was given. Okay, no need for this. Okay, the length of the block was given as 4 meters. The depth was given as 1 meters. So the depth is simply 1 meters. Okay, and the width was given as 0.5 meters. So the width was given as 0.5 meters. Now, this is a condition. They said find the volume of a concrete that may be placed on the block. So we now place a concrete on this block. So let's say we place a concrete on this block. Okay, we place a concrete on this block. This is a concrete. Okay, the specific gravity of the concrete was also given as 2.5. Specific gravity of concrete was given as 2.5. So we place a concrete on top of this block. Okay, so the question says find the volume of concrete or specific gravity 2.5 that may be placed on the block, which will immerse the block completely in water. So when this concrete is placed on this block is now immersed completely. So we have water now. We have water here. We have the concrete on the water, but then the block itself is now completely immersed in water. Okay, the block is completely immersed in water. So this is a condition. The block is now completely immersed in water, but take note, the concrete still remains on top. Okay, but the block is completely immersed in water. So these are the two conditions that we have. Now, as always, now this is the condition of the block when it is under atmospheric condition. Okay, the block here is floating on the water, not immersed in the water. So this is under atmospheric condition. So under atmospheric condition, we can simply obtain what? First, let's obtain the volume of this block. Volume of block. Okay, in air, volume of block in air, simply V air, is simply equal to, it's given 4 by 1 by 0.5. This will actually give us 2 meters cubed. This is the volume of the block under atmospheric condition. Now, we were given the specific gravity of the block, which means we can also find the weight of the block under atmospheric condition. Okay, now specific gravity. Okay, specific gravity S, we said is simply weight of block, specific weight of block all over specific weight of what? Pure water, which is a constant value. Therefore, from here, we can simply make specific weight of block subject to the formula, and it becomes, specific weight of block becomes specific gravity multiplied specific weight of water. So we have S times specific weight of water. So this simply means that the specific weight of block is simply equal to specific gravity of the block was given as 0.76 we have 0.76 multiplies the specific weight of pure water is constant, that is 9810. So this gives us 7460 newtons per meter cube. So this becomes the specific weight of the block in air. Now, having known specific weight of block, it is now ideal for us to find the actual weight of block in air. And I've always said specific weight of block is simple as saying the actual weight of the block all over the volume of block in air. So which means if we make the actual weight of block subject WB, capital WB now, becomes specific weight of block times the volume of block in air. So this becomes the actual weight of the block. So we'll do that over there. The actual weight of block in air, actual weight of block in air, okay, call this W air, is now equal to, so we said the simply specific weight, which is 7460 multiplied by the volume of block in air, and the volume of block in air gave us 2 meters. So multiply by 2, and this is equal to 14920 in newtons. Alright, so this becomes the actual weight of the block in air. Now, having known this to be the actual weight of the block in air, next is to now find the weight of the block in the liquid or in the water. Okay, next is now find the weight of the block. Remember, when the concrete is placed, the block is now what? Completely immersed in the water. So this brings us to another idea of Archimedes' principle. The principle states that when a body is completely submerged or completely immersed in a fluid, the volume of the body on air is equal to the volume of that body when immersed in the fluid. So if this object is completely immersed in a fluid, it means that this block is actually entering into the fluid with its entire volume. So which means it will also displace what? The entire volume it has inside the water. So sorry. So if the entire volume of the block on air is 2 meters cubed, if the entire volume of the block on air gives us 2 meters cubed, that means when completely immersed in water, the volume of fluid or volume of water displaced by this block is also what? 2 meters cubed, because in this case now it is completely immersed. So it has the same height, the same length, and the same width inside the water. So which means the volume remains the same when immersed completely inside the water. Alright, so we have this to be the weight of actual weight of block in air. Now, so we need to now find volume of block displaced in water. Volume of block from Archimedes' principle. Okay, so I said from Archimedes' principle, since the entire block is actually what? Immersed in the water, then it means the volume of block in air is equal to volume of block in water, and this still remains 2 meters cubed. You have this. Next is to obtain, of course, the whole thing we are trying to do now is to obtain what? The weight of the object in water. Okay, so if this is the volume of the object in water, then what is the weight of the object in water? So we already know that specific weight of water, okay, specific weight of water is a constant value. WW is simply 9810 in Newton. This is the specific weight of water. So this implies that, so to obtain the actual weight of block in the water, okay, weight of block in water is simply equal to, simply use WW, weight of water is simply equal to what? Specific weight of water multiplied by the volume of water displaced by the block. Of course, we know specific weight of water is simply what? Total weight of water or actual weight of water all over volume of water. So if we make the actual weight subject, it becomes specific weight times volume of water, which is what we have here. And specific weight of water is a constant value. The value remains 9810 multiplied by the volume of water. Now is still the volume of what? The object in air, which is 2 meters cubed. So multiply by 2 meters cubed. So this implies that the actual weight of the object in water is now equal to, this gives us 19620 in Newton. So this becomes the weight of the object in water. Now, the question is asking us to find the volume of concrete. This is the first condition now, when only the block, when this concrete pushes this block and causes the block to completely immerse in water. So we're asked to find the volume of concrete. Now, in this water, it is not only the weight of the block that is being felt. Yes, the concrete is not immersed. It is only the block that is immersed. But then, the weight of the concrete and the weight of the block is actually what being immersed, like it's actually being felt, sorry to say. The weight of the concrete and the weight of the block is actually being felt inside the water. So the total weight of block now becomes the weight of block itself and the weight of concrete. Of course, the block is carrying the concrete. So the total weight becomes the weight of block and the weight of concrete. Therefore, total weight of block in air, okay, total weight of block in air, so simply use WT, is now what? The weight of block in air plus the weight of what? The concrete itself. So this is now equal to the weight of block in air. We obtain the value to be this, okay, 14920. So we have this to be 14920 plus the weight of the concrete itself, WC. So this becomes the total weight, okay, total weight of block in air. This becomes total weight of block in air. And from Archimedes' principle, the total weight of every object in air equals the total weight of the object, equals the total weight of the fluid displaced by that object. So it means this weight is equal to the weight of water from Archimedes' principle. Okay. Alright, so recalling from the other equation, we obtain total weight of the object in air to be equal to 14,920 plus weight of concrete. Okay, so we take WC to be weight of concrete, and of course we also obtain total weight of fluid displaced, okay, weight of water as simply 19620 newtons. And we said from Archimedes' principle, of course, these two weights are equal from Archimedes' principle. So this simply implies that 14,920 plus WC is equal to 19620. So we can now find the weight of the concrete. This simply implies that weight of concrete WC is now equal to, simply send 14,920 over here, it becomes 19620 minus, of course, it becomes minus 14,920. So this simply implies that the weight of concrete in air is equal to 19620 minus 14,920, 47000 in Newton. So this becomes the weight of the total weight of the concrete, or the actual weight of the concrete in air. Now the question says we should find the volume of concrete. If we are to find the volume of concrete, not forgetting, recall, let's just do a brief tutorial here. Now we said specific weight of concrete simply means total weight of concrete all over volume of concrete. So which means if we are able to find specific weight of concrete, since we know the total weight of concrete, we can compute what the volume of concrete. So if we do across our multiplication here, we are going to simply obtain volume of concrete to be equal to what? It becomes total weight of concrete divided by what? Specific weight of concrete. So all we need to do now is what? Find the specific weight of concrete. Find the specific weight of concrete, and if we divide these two together, we obtain the volume of concrete. Now we are given specific gravity of the concrete. Okay, specific gravity of concrete was given S. It was given there as 2.5. Okay, it was given in the equation as 2.5. So if this is the specific gravity of concrete, it means now that we can find specific weight using our formula for specific gravity. Specific gravity S is now equal to what? Specific weight of concrete all over specific weight of what? Water. If you know this, you can now make specific weight of concrete subject by what? Cross multiplying. It becomes specific gravity multiplies specific weight of water. That gives us the specific weight of concrete. So we simply have here S multiplies specific weight of water. So this is now equal to specific gravity of concrete was given as 2.5 multiplied specific weight of water is a constant value. It remains 9810. So this simply implies that the specific weight of concrete is now equal to 2.5 multiplies 9810. That gives us 24530 in newtons per meter cube. So if we have this to be the specific weight of concrete and we know the total weight of concrete in air, we can now compute the volume of concrete. Simply total weight of concrete divided by specific weight of concrete. Therefore, okay, volume of concrete, okay, we said that is simply total weight of concrete all over specific weight of concrete, which is now equal to total weight of concrete gave us 4700. So we have 4700, okay, all over specific weight of concrete, which gave us 24530. And if we do this, we are going to obtain the specific volume. We are going to obtain the volume of concrete to be equal to 0.2 in meters cube. So this becomes the volume of concrete. Alright, so this becomes the volume of concrete when only the block is immersed. Now the second question says, what is the volume of concrete when both the block and the concrete is completely immersed in the water? Is completely immersed in the water. So let's look over that over the other side of the board. Okay, so I will take care of now. So we have now the concrete. Okay, this is the concrete, and we have the block. Both of them completely immersed in water. So this is water now. Okay, so both of them now completely immersed in water. Both the concrete and the block are now completely immersed in water. On air, this whole condition remains the same. Volume of block in air remains 2 meter cube. Of course, specific gravity and all that, the weight of block in air, every other calculation here remains the same. But then we now have that the both blocks are immersed in water. What now changes now is now the weight of fluid displaced by the object in water. Why? Because now we have both the concrete and the block completely immersed in the water. And I said from Archimedes' principle, if an object is completely immersed in water, it means that the volume of water displaced by that object is equal to the volume of the object on air. Now, the volume of the object on air becomes what? Volume of the block plus the volume of the concrete. Then that is the total volume of water. That is the total volume of the object on air. Then when submerged in water, it is still the volume of the block and the volume of the concrete now are completely submerged in water. They are not floating. So which means that the volume displaced or volume of fluid or water displaced by these two objects is simply what? Also the total volume of the concrete and total volume of the block. Simply because the both of them actually what? Is completely or are completely immersed. No one is floating. So it means when a body is completely immersed, the volume of fluid displaced becomes the total volume of the body immersed from Archimedes' principle. Alright, so let's get that over the other side and see. Alright, so the only thing we're going to be changing here now, of course, this remains the actual weight of the block in air. It doesn't change. Now, from Archimedes' principle, we're going to alternate a bit now from this principle. Now, the volume of water displaced now becomes total volume of components in air. because it is these two components now, the concrete and the block, that are actually immersed completely in the water. So total volume displaced becomes volume of block and volume of concrete. Okay, so we are going to now adjust that from this Archimedes principle. All right, so I'll take here off. All right, so from Archimedes principle now, the volume of water displaced is now equal to volume of block itself plus volume of concrete. And we know the volume of the block, it was given, volume of block in air was given as 2 meter cube. So this is actually what? 2, okay, plus the volume of the concrete. And this is what the question is asking us to find. Volume of the concrete when both the block and the concrete is completely immersed. So this is simply plus VC, which is the volume of the concrete. So this becomes the volume of water displaced by these two objects when they are completely immersed in the water. Now, if you know this, the next thing for us to find is what? Obtain the weight of water displaced. Okay, we need to find the actual weight or the actual weight of water displaced. We already know that specific weight of water. Okay, we already know that specific weight of water is simply small w, that gave us 9810 in newtons per meter cube. And we said to obtain total weight of water, okay, this is now equal to what? The specific weight of water multiplied by volume of water displaced. So this is now equal to, specific weight of water is constant, 9810 multiplied by volume of water displaced is now volume of block plus volume of concrete, who gave us 2 plus VC. So we have 2 plus VC, which is equal to this. Therefore, the total weight of water is now equal to what? 9810 multiplied by 2. That gives us 19620 plus 9810 multiplied by VC give us 19810 VC. So we simply keep this aside. This becomes the weight. Okay, keep this equation aside. This becomes the total weight of water displaced by that object. Now, from Archimedes principle, total weight of water equals total weight of what? Block in mass. And we already obtained here that total weight of block in mass is simply weight of block in air plus the weight of concrete, which actually gave us this. So it means now that from Archimedes principle, these two equations are equal. Weight of water equals total weight. So we're simply going to equate the whole of this to the whole of this. That is just the idea. It's as simple as this. Okay, so let's do that over the other side. All right, so equating now the previous two equations shown over there for total weight of water and of course total weight of block. Okay, total weight of block give us 14920 plus WC, which is the weight of concrete, and this is now equal to total weight of fluid displaced by by the block itself. And total weight of fluid displaced by block gave us 19620 plus 9810 VC. Okay, but not forgetting that, okay, recall total weight of the concrete, of course, WC simply means specific weight of concrete multiplied by volume of concrete. If we multiply concrete by its volume, we are going to have the total weight of the concrete on air. And we already obtained the specific weight of the concrete to be this value, 24530. So it means that the total weight of concrete is now what? 24530 multiplied by what? VC, which is the volume of concrete. So in place of this, we can put in this value for it. So we are going to have this equation to become 14920 plus, in place of WC, we put in this value 24530 VC, and that's equal to everything we have here, 19620 plus 9810 VC. Okay, let me take care of now. All right, so we have this. So all we need to do at this point is simply what? Collect like terms. Send 24530 or send this man, okay, 9810 VC over here. Send this man over there. That's all we need to do. So first, we send 9810 VC over here. We have 14920 plus 24,530 VC, of course, plus 9810 VC crosses this equal to and becomes negative. So I have minus 9810 VC, and this is equal to, so I'm left here now with 19620. Next, I will send 14920 over here. So this is a constant. Transfer it over here so that I have just terms in BC here, and then I have a constant values here. Okay, so I'll have 24,530 VC minus 9810 VC. That's equal to 19620 minus, okay, this comes here becomes minus, of course, 14920. All right, so we'll obtain 24530 VC minus 9810 VC. 14720 VC, and this is now equal to 19620 minus 14920. That gives us 4720. Okay, so from here we can make volume of concrete subject. This now implies that VC is simply what? 4720 divides 14720. So this implies that volume of concrete is now equal to 4720 divides 14720. That gives us approximately 0.32 in meters cubed. So this becomes the volume of the concrete when both the concrete and the block is completely submerged in water. All right, guys. So I hope you find this video very interesting and helpful. Please, if you do, I would like to get your thoughts on the comment section. And of course, if you have any question at all to ask, you can do well to DM me on WhatsApp or also do that on the comment section. I promise to respond to all your questions. Till I see you in the next video. Thanks and cheers.